Have you ever wondered how to build a robot from scratch? Picture the thrill of seeing your very own robot spring to life, guided by your programming. In this journey, we're going to demystify the process of constructing and programming a robot, a process that's as much an art as it is a science. Robotics, a field that's continually evolving, holds immense potential for the future, influencing sectors from healthcare to space exploration. By building your robot, you're not just assembling metal and wires, you're creating a piece of the future. It's an experience that's rewarding, challenging, and incredibly exciting. You'll learn, grow, and perhaps even surprise yourself with what you're capable of. So, whether you're a seasoned techie, a curious beginner, or somewhere in between, this is your opportunity to dive headfirst into the captivating world of robotics. Stay tuned as we dive into the fascinating process of building and programming a robot. First things first, it's crucial to define your robot's purpose and design. This is the foundation upon which the entire project rests. Having a clear idea of the type of robot you want to build and what you want it to do will guide every decision you make along the way. When considering your robot's purpose, think about what you want it to achieve. Do you intend to create a robot that can help clean your house? Or perhaps you're interested in a robot that can perform complex tasks like a full-fledged humanoid? Maybe you just want to build a simple device that moves around avoiding obstacles. The options are limitless and the choice is yours. Next, let's talk about design. This includes considerations like how your robot will move. Will it wheel around, walk on multiple legs, or perhaps even fly? Your robot's movement capability will have a significant impact on its design and the complexity of your project. Speaking of complexity, it's important to be realistic about your skill level and resources. If you're a beginner, starting with a simple design can be a great way to learn the basics. As you become more comfortable with the process, you can gradually take on more complex projects. And remember, the design process is not just about defining the physical attributes of your robot. It's also about determining the intellectual capabilities you want your robot to have. Will it follow a set of pre-programmed instructions, or will it be capable of learning and adapting to its environment? The world of robotics is incredibly diverse, spanning everything from simple mechanical toys to advanced AI-powered machines. Each type of robot has its own unique applications and challenges, and understanding these will help you define a clear and achievable purpose for your project. So, take some time to brainstorm, do your research, and sketch out your ideas. This is your chance to be creative and innovative. There's no right or wrong design, and the best part is that you can always refine and improve your robot as you learn more. With a clear design and purpose, you're ready to gather the necessary materials and components. And remember, the journey of building a robot is just as exciting and rewarding as the end result. The next step involves assembling the necessary parts. Building a robot from scratch requires a few key components. First, you'll need a microcontroller, which acts as the brain of your robot, controlling all of its functions. Then, you'll need a programming board to write and upload the code to the microcontroller. Sensors are also essential. They allow your robot to interact with its environment, detecting objects, light, sound, and more. Don't forget about motors, which provide movement, and batteries to supply power. And of course, you'll need wires to connect everything together. If sourcing these parts individually sounds daunting, don't worry. There's another option, a robot kit. These kits come with all the necessary components, often tailored to specific types of robots. This can be a great option, especially for beginners. Once you have all the components, it's time to assemble your robot. Now comes the exciting part, assembling your robot. Once you've gathered all the necessary components, it's time to put them together. This process is a bit like solving a puzzle. Each piece has its place, and when they all come together, they create something truly remarkable. Your design plan is your roadmap. It's there to guide you through the process of connecting all the components. You'll want to start with the heart of your robot, the microcontroller. This is the brain of your robot, controlling all of its functions. Connect it to the programming board, which will allow you to write and upload code to the microcontroller. Next, attach the sensors. These are the eyes and ears of your robot, allowing it to interact with its environment. They connect to the microcontroller and relay information back to it. Depending on your design, you might use light sensors, temperature sensors, or even motion sensors. Then, it's time to install the motors. These are the muscles of your robot, giving it the ability to move. Connect them to the microcontroller through the motor driver, which controls the speed and direction of the motors. Now, don't forget the power. The batteries provide the energy your robot needs to function. Connect them to the power supply circuit, which distributes power to all the components. As you connect each component, you may need to use tools like a soldering iron to create secure connections and a breadboard to prototype and test your circuits before making them permanent. Once all the components are connected, you can start building the chassis or frame. This is the body of your robot, housing all of its components. You can create it from various materials, depending on your design. Remember, building a robot is a journey, not a destination. It's okay to make mistakes and learn as you go. The important thing is to keep trying, keep learning, and most of all, have fun. With your robot assembled, you're ready to program it. Now that your robot is assembled, the next step is to program it. Programming is the brain of your robot, dictating its behavior and responses to the environment. This is where the magic happens, and your robot comes to life. First, you need to pick a programming language. This choice depends on the microcontroller you're using. Some common languages used in robotics include Python, C++, and Java. Python is well loved for its simplicity and readability, making it a great choice for beginners. C++ offers more control over the hardware, while Java is used extensively in industrial and commercial robots. Once you've chosen your language, it's time to write your code. This is where you tell your robot what to do and how to react. Your code will be a series of instructions, like a recipe that your robot follows. Let's delve into some key elements of programming. You'll be using variables, loops, functions, and conditional statements. Variables are like containers that hold data. For instance, a variable could store the distance between your robot and an obstacle. Loops are used to repeat a set of instructions. If you want your robot to move forward until it encounters an obstacle, you'd use a loop to continually check for that obstacle. Functions are reusable pieces of code. They simplify your program and make it easier to read and debug. For example, you might have a function that makes your robot spin in a circle. Conditional statements, or if statements, allow your robot to make decisions based on certain conditions. If the robot is too close to an obstacle, it could turn around. Remember, programming can be a trial and error process. It's okay to make mistakes. Each error is an opportunity to learn and improve. Take it one step at a time, and don't be afraid to ask for help. There are countless online communities and resources ready to assist you. With your robot programmed, it's time to test and debug it. This is where you'll see the fruits of your labor and marvel at your creation as it springs to life. The final step in building your robot is testing and debugging it. It's like administering a final exam to your mechanical student. This step is crucial as it ensures that the robot is functioning according to your design and programming. Just as we humans learn from our mistakes, our robot can learn from its own errors, thanks to debugging. Debugging allows us to identify and fix any discrepancies in the code or hardware. It's like the robot's own self-improvement tool. After uploading your code, it's time to test your robot. It's a thrilling moment watching your creation come to life. If it doesn't perform as expected, don't be disheartened. It's not a failure, but an opportunity to refine your work. Use debugging tools to rectify the errors. Tinker, tweak, and test again until your robot behaves as planned. Congratulations, you've just built and programmed your own robot from scratch. Building a robot from scratch is an exciting and rewarding journey. We've navigated through defining your robot's purpose and design, gathering the necessary materials and components, assembling your robot, programming it, and finally, testing and debugging. Remember, each of these steps is a learning opportunity. As you document your creations, you're not just building a robot, you're building knowledge, skills, and experience. Sharing your work with online communities can open doors to constructive feedback, new ideas, and inspiring collaborations. And let's not forget the joy of exploration. As you continue to delve into the world of robotics, you'll discover more about its vast landscape and your unique place within it. Each robot you build is a stepping stone to the next, each line of code a foundation for more complex programming. Thank you for joining us on this robotic adventure. Remember, the possibilities are endless when you start to build and program your own robots.